now we're making a rule for composite functions. And if you don't know what a composite function is, we'll kind of talk about that in this video as well to refresh your memory of what a composite function is. So first of all, a composite function is one function inside of another function. So I could say y is defined as f of g of x, where g of x is the function inside of f. So if I said like g of x was sine of x and f of x was x squared plus x minus 2, I'm going to write over here, then y would be equal to x squared plus x minus 2, right? I'm going to just plug g of x is plugged inside of f. So now I'm going to plug g of x inside of that. So I'd have sine of x squared plus sine of x minus 2. That's what a composite function is. And it's good to be able to decompose a function into two functions when you see one. So for this function, f of x here, I can think of that as a composite function of g of x and h of x. G of x would be x cubed, h of x would be 2x plus 3, and I'll call them the inner and the outer functions. That would be the inner and that would be the outer. So I could say this function f of x is really g of h of x. I took h of x and I plugged it in to g of x for x. And that's how I arrived at this composite function. So writing the g and the h is decomposing the function, and I'm looking at the outer and the inner. We're not going to worry about that right now when we do this derivative. We're going to do this derivative the way we know. I'll teach you the chain rule, and then we'll use chain rule on the same function and show that we get the same derivative. So if we want to rewrite this as a polynomial, we've got to do 2x plus 3 times 2x plus 3 times 2x plus 3. Oops. So I'm going to get 4x squared plus 6x plus 6x plus 9 times 2x plus 3. Of course, the 6x plus the 6x becomes a plus 12x. Now when I multiply again, I'm going to get 8x cubed plus 24x squared plus 18x. Now I distribute the 3 plus 12x squared plus 36x plus 27. Can I combine anything here? I can combine the x squareds. So my f of x is now 8x cubed. For my x squareds, I've got 36. For my x's, I've got what? 36, 40, 54. And then plus 27. So now I want to take the derivative of that, and I'll get 24x squared by power rule plus 72x plus 54. So there's our derivative. So now we're going to look at how do we do this with chain rule so we don't have to multiply this out. Because that's fine if it's to the third, but what if that's to the fifth? I don't want to multiply that out, right? I want to learn a rule to take the derivative of composite functions. So again, we have to know that means a function, we'll call it h, is defined as one function inside of another function, f of g. Remember that I'm going to call g my inner function, and I'm going to call f my outer function. So if our function is defined as that, then the derivative of that function, so then h prime of x, the rule that we're going to use for this is to take the derivative of the outer, recopy the inner function when we do the derivative of the outer, so we don't touch it, and then at the end multiply by the derivative of the inner function. That is our rule for chain rule. So let's now use that rule on this function. So f prime of x is, well, let me rewrite f so we have it down here. So f of x equals 2x plus 3 to the third. So the way that I talk through this one is I say, first we take the derivative of the outer. I've identified the outer function as x to the third. Right? So you can think of this as one big giant x. And we're just doing power rule on that. So the 3 comes down. I recopy the inner. I reduce the power by 1. That is this part of the rule. I just did the derivative of the outer. I thought of the inner as a giant x here. Right? So I just kind of recopied that part. Right? I didn't do the derivative of that 2x plus 3. And that's the key. That's the mistake that we typically make. So I'm going to back this up so I can get rid of that x now. All right, so my outer function is considered x to the third. So I bring the 3 down. I'm doing power rule on that. So what I say is bring the 3 down, recopy the inner function, because we usually do that in power rule, right? If I did power rule on this, I go 3. I recopy the base or the inner function of x, and then I reduce the power by 1. So that's all we've done here is we've taken the derivative of the outer function times the derivative of the inner function. So now we're doing this part. The derivative of the inner function on its own is just 2x plus 3. So the derivative of 2x plus 3 is 2. So then our derivative, this is 3 things times each other, so I can reorder, bring the 2 out front, write it as 3 times 2 times 2x plus 3 squared. I get 6. Times 2x plus 3 squared. That's our derivative. Now, does that derivative match this one? It will. If I multiply out the 2x plus 3 squared, then distribute the 6. So let's do that. 6 times 4x squared plus 12x plus 9. I distribute the 6. I get 24x squared plus 12 times 6 will be my 72x. And then 9 times 6 is 54. So there's my final derivative. Okay, so now we're going to apply this to find the slope of the normal line to this graph. The first thing you need to remember is that sine squared of theta is shorthand. It really means sine of theta times the whole thing squared. It's going to be helpful to rewrite like this when we're using chain rule to find the derivative. Now we want the slope of the normal line, which means we need the derivative, which will give us the slope of the tangent line. If I apply chain rule, my outer function here is x squared, or in this case I'll go theta because these are in thetas, theta squared. And my inner function is sine of theta. So remember, chain rule says do the derivative of the outer first. So I'm applying power rule on this thing. The 2 comes down. I recopy the inner when I do power rule with chain rule here. Reduce the power by 1. You don't have to show that 1 right there, but I'm going to show it. So then I do the second part of chain rule says times the derivative of the inner, right? The inner function sine, so it's me times the derivative of sine of theta, which is cosine of theta. So my derivative is 2 times the sine of theta times the cosine of theta. So if I plug in a 3 pi over 4, oops, that's not neat. That should be equal to, let's see, pi over 2, 3 pi over 4 is over there in quadrant 2, so it's going to be 2 times, the sine value will be positive, the cosine value will be negative, so this 2 reduces with one of those 2's, so it's going to be over 2. It's going to be a negative, a root 2 times a root 2 is a 2, it looks like it's going to be negative 1. That's the slope of the tangent line. So then the slope of the normal line is going to be the opposite reciprocal of that, which is 1. All right, now we're going to just practice taking the derivative with chain rule. So again, I like to identify your outer functions and your inner functions. So the outer function here is x cubed. The inner function is 3x squared plus 2. Chain rule says take the derivative of the outer. So I'm applying that rule there. That's power rule. So the 3 comes down. I recopy the inner. Reduce the power by 1. I did the derivative of the outer, and I recopied the inner while I did it. In chain rule, right, that's this part right here. Derivative of outer, recopy the inner. Now it's times derivative of the inner. So times the derivative of the inner function, which is that guy, so it's going to be 6x. So then we're going to write f prime of x as, let's see, we'll say 18x, 3x squared plus 3. And this would be acceptable here. You can multiply it out and turn it into a polynomial if you like. I'm going to accept that answer there. We like stuff factored typically for answers. If I was going to take the derivative of something, I don't want it factored. All right. This one requires a rewrite to the 1/2. My outer function is then x to the 1/2. My inner function is 2x plus 5. Again, if I took this and plugged it into that function for x, I would arrive at this composition function. So we're now going to do the derivative of the outer. So that's a power rule on this guy, right? X to the 1/2. So 1/2, recopy the base to the negative 1/2 times the derivative of the inner. Okay, so now here's the part where we talk about the simplification. I see this as 3 things times each other. I put parentheses around the 1/2 just to show or stress that it's going to be multiplication of 3 things. So the way we're going to do this is the 1/2, if any one of these is a fraction, that sort of defines our fraction. Since this guy is a negative exponent, it's going to make it 1 over that to the positive, and it's going to multiply into the bottom as a positive. This 2 has a positive exponent of 1, so it's going to stay in the top. So then I've got g prime of x equals 2 over 2 times the square root of 2x plus 5. If I simplify that, I get 1 over the square root of 2x plus 5. Okay, let's move on to the next one. Again, this is going to require a rewrite. H of x equals x plus 2 to the 2/3 power. So this is just like the last one. The outer function would be x to the 2/3. The inner would be x plus 2. So if I take the derivative of the outer, that's power rule. So the 2/3 comes down. I recopy the inner. I reduce the power by 1. I like to show that minus 3/3. So I get a negative 1/3. Then times the derivative of the inner, that's power rule again. The derivative of the inner function is just 1. So now I've got h prime of x equals, again, I've got 3 things times each other. One of those is a fraction, so I've got my 2/3. This has a negative exponent, so it's going to end up in the bottom as a positive exponent. That 1's going to multiply into the top. So I'm going to get 2 over 3 times the square root of x plus 2. Oh wait, no, that's not a 1/2. I'm sorry, it's a 1/3. So it's going to be the cube root of, so 2 over 3 times the cube root of x plus 2. Our next one, again, will require a rewrite. So it's going to be 5 times x squared plus 2x to the 1/3. So our outer function is really 5x to the 1/3. Our inner is really x squared plus 2x. So when I do my derivative, I do power rule because I'm doing derivative of the outer. So the 1/3 comes down. I recopy the inner. I reduce the power by 1. So I get a negative 2/3. That's the derivative of the outer while recopying the inner times the derivative of the inner. So now that's a power rule. So it's going to be 2x plus 2. That's a binomial, so it's got to be in parentheses when I multiply it. Again, I have three things times each other. So the 5/3 is going to kind of set up the fraction. This one's going to end up in the bottom as a positive 2/3. This one's going to end up in the top because its exponent is a positive 1. So we're going to end up getting 5 times 2x plus 2 over 3 times the cube root of x squared plus 2x squared. And that'll be good enough. Some of you would factor out the 2 up top and call it 10 times x plus 1 up top. Or we can multiply it back out and get 10x plus 10 if we multiplied the 5 out. Any one of those numerators is acceptable. All right, let's do this derivative. So I'm going to require a rewrite here when I have a trig function squared. So g of x, this is not prime. G of x is going to be equal to cosine of 3x, and then that whole thing squared. That's what this means. So my outer function is x squared. My inner function is cosine of 3x. And then this itself is another chain rule. So I'll have another inner function of 3x. So I just kind of have to keep peeling off layers and going inside times the derivative of the inner times the derivative of the inner. So let's do that. G prime of x is going to be equal to, I'm doing power rule on the outermost function. So the 2 comes down, I recopy the inner, reduce the power to 1. Now times the derivative of the inner, which is this guy. And that's a chain rule in itself. So I'll start with the outermost part. So the derivative of that, the outermost thing, is cosine. So the derivative of cosine is sine. I recopy that inner without touching it. Then times the derivative of the inner. So that's 3. Okay, so now I see this as 1 times 2 times 3 times 4 things. You can't multiply into these angles of the trig functions. You can only switch around the 3 times the 2. I'll bring that 3 all the way to the front, make it a 6. The derivative of cosine is negative sine. Sorry, I forgot about that. Not positive sine. So that's like a negative 1 that I multiply in there. So I'm actually going to have a 3 times a negative 1 times a 2. So it's going to be a negative 6. And then it's going to be cosine of 3x times sine of 3x. Remember, these 3x's are not like, it doesn't mean multiplied by cosine. It's inside the cosine. You can't do any algebra with that. Okay, so on this guy, it's more the same. So we've got a rewrite. Whenever I see a trig function to a power, I'm going to think of it as sine of 2x plus 1 to the whole thing squared. So my outer function is x squared. My inner function is sine of 2x plus 1. And again, that's a chain rule in itself. That's a composition of functions with an outer and an inner function. So there's one more inner after that. That's 2x plus 1. So we have to keep peeling off those layers. So the derivative, I start with the derivative of the outermost function, x squared, and I do my power rule on that. And I have to recopy the inner while I execute that rule. So this is derivative of the outer by power rule while recopying the inner, times now the derivative of the inner. So the derivative of sine is cosine, but it has an inner function, so I don't touch it. I recopy it the first time through, and then I multiply by the derivative of that inner. So that's a 2. So again, I see this as 2 times the sine of that. Remember, this is part of the sine, this 2x plus 1, times the cosine of that angle times 2. So we can do the 2 times the 2, and we get a 4 sine of 2, 4 times the sine of 2x plus 1 times the cosine of 2x plus 1. And that's our derivative there. Now we're going to see how you can use some of these rules all together. Let's see. So we can kind of use product rule with chain rule and quotient rule with product rule, all that kind of stuff. We're going to mix them all up. Chain rule with quotient rule. All right, so this one starts off, you have to look at the outermost structure. So I've got a product rule. I've got 2 functions here times each other. So it's really going to be a product rule to start. In the process of doing the product rule, one of the derivatives of one of these 2 products is going to be a chain rule as I go. All right, so first this requires a rewrite of 5x times x plus 3 to the 1/2. So I'm doing product rule where this is my first function and this is my second function. So the derivative is going to be the derivative of the first times the recopy the second. So that's going to be x plus 3 to the 1/2 power. Plus, recopy the first, 5x, times the derivative of the second. Typically, when it's a chain rule, I'll just put brackets here to remember that it's all this stuff times the 5x. The brackets don't mean anything special other than it's really just the derivative of the second. So this is a chain rule. If I just pull that second function out for a second, that's a chain rule because I have an outer function of x to the 1/2, and I have an inner function of x plus 3. So I have to treat this like a chain rule. Do the derivative of the outer. So the 1/2 comes down. I recopy the inner, and I reduce the power by 1. So I did a power rule on that outer function. Now times the derivative of the inner. So the derivative of x plus 3 is just 1. So there is product rule with chain rule in it. The next thing we do is what I would call term cleanup. Because product rule has addition in it, it automatically separates us into two terms here. And inside those terms, it's all multiplication. So I just kind of reorganize that multiplication before I start simplifying. So this one, there's not much to do in terms of reorganizing the multiplication. This guy, there will be some stuff to do. I look at it as 5 times x times 1/2 times the x plus 3 to the negative 1/2 times 1. So I've got 1, 2, 3, 4, 5 things factored. There's no distributive property here because there's no addition in between these guys. Sometimes we think that because I put brackets, those brackets just denote that that's the derivative of the second. And I like to put them in brackets in case there's negative signs. It just makes it clear that it's multiplication. That's what those brackets do for me. You don't have to put them in there. So since all of these things are multiplied together and one of them is a fraction, I'm making one big fraction where the 2 is on the bottom and the 1 is on the top. So this 1/2 is defining the fraction. 5 has a positive power of 1. X has a positive power of 1. So those end up in the top. This has a power of negative 1/2. So it ends up on the bottom as a positive power. This 1 has a positive power of 1. So it ends up on the top. So now I've got 5 times x plus 3 to the 1/2 plus 5x over 2 times x plus 3 to the 1/2. So now I want to get a common denominator and add these together. So that's like over 1. So I'm going to give myself a little room here so I can show this common denominator work. So if my common denominator is 2 times x plus 3 to the 1/2. This one didn't change. What do I have to multiply that other function by? Let's look at that. So I have to multiply the bottom by 2 times x plus 3 to the 1/2. So I got to multiply the top by 2 times x plus 3 to the 1/2. So I can multiply the 5 and the 2. This is all multiplication. 4 things multiplied together. I can multiply the 5 times the 2 to get me a 10. And I can multiply this x plus 3 times that x plus 3 because the bases are the same. And if I have a 1/2 and a 1/2 power, when I multiply bases that are the same, I add the powers, so it would just be a power of 1, which I don't need to show. Now I can rewrite this as one fraction. 10 times x plus 3 plus 5x all over 2 times x plus 3 to the 1/2. Now we can multiply out the top and simplify a little bit. So I've got a 10x plus 30 plus 5x all over 2 times the square root of x plus 3. I'll change that back to a root. So I've got f prime of x equals 15x plus 30 over 2 root x plus 3. And you could leave it there, or you could say, hey, if 15 factors out, so it's x plus 2 over 2 times the root of x plus 3. All right, let's try another one. This one has a couple rules going on in here. It's got a rule for sine. We have to know that the derivative of sine is cosine. It's got a quotient rule. It's a chain rule because we have a function plugged into sine, not just sine of x. It's like an actual function in there. So this has a whole bunch of stuff going on. This is a sine rule, a quotient rule, a chain rule. So you got to kind of focus on the outermost structure. Here, the outermost structure was product rule, two functions times each other. Here, this does not mean multiplication. This is the biggest mistake. I keep trying to stress that it's not sine times this, because if you think it's sine times this, you're going to try to do product rule. It's sine of this. This is the thing plugged into sine. This is your reference angle. It's sine of that. So your outermost structure is chain rule. So we're going to start by doing chain rule here. And chain rule says, take the derivative of the outer function, which is sine, recopy the inner function. So my angle for cosine stays the same. But now times the derivative of the inner function. The inner function is this quotient. So the top function being f, the bottom function being g. So my quotient rule says f prime, so the derivative of the top is going to be 2 times recopy g minus recopy f times the derivative of g, the bottom, all over g squared. Okay, so now what we're going to do is typically we like to write our polynomial or any of our functions in front of our cosine. Remember, we cannot multiply these. Cosine of this angle is its own thing. You cannot multiply into the angle. So we're going to reshuffle this and put this guy out front, x minus 3 squared. And let's simplify the numerator as we go. 2x, the 2 is going to get distributed. This negative 1 is going to get distributed. So up top, I'm going to have 2x minus 6 minus 2x minus 1. That whole thing times the cosine of 2x plus 1 over x minus 3. So the 2x minus the 2x is 0. So I get negative 7 over x minus 3 squared times the cosine of 2x plus 1 over x minus 3. Let's do another one that's got a bunch of different rules in it. This one, the outermost structure here, is quotient rule. So you can see we have one function divided by another function. And I can do a rewrite here, 2x plus 5 to the 1/2. So I'm going to apply quotient rule here. And when I start applying quotient rule, I'm going to run into a chain rule where I've got a composition of functions. This numerator is a chain rule. 2x plus 5 has been plugged into the outer function of x to the 1/2 would be my outer, and my inner would be 2x plus 5. So when I'm executing quotient rule, when I go to take the derivative of the numerator, I'm going to have to apply chain rule. So let's take a look at how that works out. So I start off by doing f prime. So I've got to do the derivative of the top. So that's a chain rule. So I do the derivative of the outer, meaning bring the 1/2 down, recopy the inner function, reduce the power by 1. So that's the derivative of the outer while not touching the inner times the derivative of the inner. Okay, so that's the derivative of the numerator. I'll bracket it just to show that, times recopy the denominator, minus recopy the numerator times the derivative of the denominator, which is just a 1, all over denominator squared. That is our quotient rule. So we're going to start simplifying this. So just like product rule, when our outer structure is quotient rule, we're separated by that minus sign. We've got two terms here. So we're going to do term cleanup in each one. So over here I've got 1/2 defines my fraction. This is a negative exponent, so it ends up in the bottom as a positive exponent. This times 2 has a power of 1, so it's going to end up in the top. And then times the x minus 3, because x minus 3 has a positive exponent, stays on top. Minus, over here it's just going to be 2x plus 5 to the 1/2, all over x minus 3 squared. Let me plug my Apple Pencil in for a second. I'll pause the video while it charges. All right, so we're going to recopy this and do a common denominator work with the numerator. Now, before I recopy, I noticed that this 2 can divide into that 2. So we've got up top, we have a common denominator. You can think of this, I'll do it in another color, as over 1. So our common denominator is going to be 2x plus 5 to the 1/2. That I should write that down here, sorry. 2x plus 5 to the 1/2. So on this guy, my numerator stays the same, x minus 3. And we're not doing anything with this denominator yet. And then this numerator, I multiplied the denominator by 2x plus 5 to the 1/2. So I got to multiply the top by 2x plus 5 to the 1/2. Because these have the same base, I can multiply them. So I'll get 2x plus 5. And I have a negative 1/2 and a negative 1/2 power. So when I multiply the bases, I add those powers together to get a first. And I don't need to show that. So now we're going to subtract these. 2x plus 5 to the 1/2 over x minus 3 squared. And this is going to be an x minus 3 minus the quantity 2x plus 5. Don't forget that this minus out in front of the fraction means it's times the whole numerator. So for our final rewrite, or maybe not it's final, it's not final, but I'm going to go x minus 3. I'm going to distribute this minus sign, minus 2x minus 5 over x minus 3 squared times 2x plus 5 to the 1/2. What happened there? Remember, you think of this as over 1. So instead of dividing by that fraction, I'm going to multiply by the reciprocal of it. So I end up just, instead of dividing by that, I multiply by its reciprocal. And so these are just going to multiply together in my denominator here. Okay, now I can simplify my numerator. X minus 2x is negative x. And then negative 3 minus 5 is negative 8. All over x minus 3 squared times the square root of 2x plus 5. There's our derivative. Okay, now let's do some stuff with graphs and tables, and then we'll be done here. All right, so we have a graph pictured to the right here. It's h. They want the equation of the tangent line drawn to that graph. So first we need the point of tangency. So that means at x equals negative 4. So I need p of negative 4 to get the y value. So that's going to be the square root of h of negative 4. So if I find h of negative 4 from the graph, that's right here, its y value is 4. So then that's going to be the square root of 4, which is equal to 2. So our point of tangency is negative 4, 2. That's our point of tangency. Now we need the slope of the tangent line. And that's going to be finding p prime of negative 4. So we notice that when we go to do the derivative of this, it is a chain rule because it's an outer function and an inner function. So I can look at p of x as h of x, that inner function, to the 1/2 power. So my outer function would be x to the 1/2. My inner function would just be h of x, which I just have a graph for. All right, so what we're going to do is find p prime of x. So p prime of x, applying chain rule, we do the derivative of the outer, which is considered x to the 1/2. So this 1/2 comes down. I don't touch the inner function. I recopy it. I reduce the power by 1 times the derivative of the inner. So now p prime of x simplifies. I see this as 1, 2, 3 things times each other. So the way I simplify it is, since one of those is a fraction, that defines our fraction. This negative 1/2 puts it in the bottom as a positive 1/2, which I'll rewrite as a square root, and then times h prime of x in the numerator. So now if we want to do p prime, we want to find p prime of negative 4. We've got h prime of negative 4 over 2 times the square root of h of negative 4. So h prime of negative 4 means when we're at negative 4 on this graph of h prime is the slope of the tangent line, or the slope of the graph. Since it's a line, we just need the slope of that line. So if I count off the slope, I go down 1, right 2, That gives me a slope of negative 1/2 over 2 times the square root. So we already did the square root of h. We got that to be a 2, right? We did this up here, but we can go through the motions again. H of negative 4, the y value of that is 4. So then I can simplify, and I get negative 1/2 over 2 times the square root of 4, which is going to give me a 2. So that's going to be 1/2 over a 4. And then if I simplify that, it's going to be negative 1/2 times 1 over 4 instead of divided by 4 over 1. So it's going to be negative 1/8. That's going to be the slope of our tangent line. So now we can write the equation. It's y minus 2 equals negative 1/8 times x plus 4. There we go. All right, we got some table work and we're done. Last 3. Is the graph of h of x, if it's defined as f of g, so that's an outer function and inner function, is that function increasing, decreasing, or at relative max or min when x equals 3? Give a reason for your answer. So if we want to know if something's increasing, if the function is increasing or decreasing, we need h prime if we want to speak about h being increasing or decreasing. So let's find h prime of x. So we do our chain rule. The derivative of the outer is f prime, recopy the inner, times the derivative of the inner. So there's our derivative. We want to calculate what is our derivative at 3, or evaluate our derivative at 3. So it's going to be f prime of g of 3 times g prime of 3. So based off of our table, f prime of, I got to do what g of 3 is. I start on the inside out here when I start evaluating. So g of 3. So here's 3 on our table. G of 3 is 4. So I can replace g of 3 with 4. Times g prime of 3 is 6. Okay, so now I have to find what f prime of 4 is. F prime of 4 is negative 4, so that replaces that, times 6. So I'm getting, wait, did I do this not correctly? I feel like I made a mistake here because I already worked it out and got a different answer. Let's go back up to here for a second. G of 3 is 4, so I have that correct. And then f prime of 4. So now I'm not in this table anymore. F prime of 4 is not negative 4. F prime of 4 is 8, because now I'm on this row, f prime of 4. So I shouldn't highlight that row. So you got to pay attention to your x's there. So f prime of 4 is 8, and then I get 48. So my derivative, h prime of 3, is equal to 48. If the derivative is positive at an x value of 3, then that means h of x is increasing at x equals 3 because h prime of x is bigger than 0. All right, so this guy, more of the same. We got to do some table work here, do some chain rule. So in this case, my outer function is g of x, and my inner function is 2x. So they just want to know what's the derivative of p evaluated at 1. So if I do the derivative of p, I do the derivative of the outer, g prime, but I recopy the inner. So that's the derivative of the outer function, recopy the inner, times the derivative of the inner. The derivative of 2x is 2. So now we want to evaluate p prime of 1. So that means if I plug 1 in, I get g prime of 2 times 1 times 2. So I'm going to say p prime of 1 is equal to g prime of 2. I got to simplify inside there, times 2. So then p prime of 1 equals g prime of 2. So g prime is here, and then for an x value of 2, we're getting negative 1 times 2. We get negative 2. So I should rewrite p prime of 1 equals negative 2. We evaluated the derivative at 1 as negative 2. All right, I'm going to try to make it here. It's a race against time with my Apple Pencil. All right, so I'm going to rewrite q of x for a second. We're going to write it as f of x plus g of x to the 1/2 power. So this is a chain rule to find the derivative. They want us to know what is the value, the derivative evaluated at 4. So we'll start with that. So we have to find the derivative of this thing. The derivative is the derivative of the outer 1/2 times recopy the inner f of x plus g of x. Reduce the power by 1. So that's the derivative of the outer function. I applied power rule times the derivative of the inner. So it's a polynomial, so it's the derivative of f plus the derivative of g. So there's our q prime of x. Now we can simplify it a little bit. So q prime of x, I see this as 1, 2, 3 things times each other. So I've got my fraction, 1 on top, 2 on the bottom. This f of x plus g of x to the 1/2 power goes on the bottom. And on top, I've got f prime of x plus g prime of x. So now I want to do q, the derivative evaluated at 4. And I'm going to rewrite this 1/2 as a square root as I do this as well. So it's going to be f prime of 4 plus g prime of 4 over 2 times the square root of f of 4 plus g of 4. Okay, so now we're going to go to the table and grab all of these numbers. In an effort to save time in this race against the Apple Pencil, I've already went to the table and grabbed these numbers. You can confirm they're right by doing it on your own. If you want to pause the video, get ahead of me and see if you get the right answer. So I got 8 plus negative 2 over 2 times 1 plus 7 over, so that's going to be 6 over 2 root 8. So we can simplify that to the 2 and the so we get 3 over root 8. I'm not going to make you rationalize. We can just kind of stay there. That is our value. So q prime of 4 is equal to 3 over root 8. It also said, what does this value say about the graph of q when x equals 4? And give a reason for that. This means that q of x is increasing when x equals 4 because q prime of x is bigger than 0. 42 minutes.